Hi everyone, this is Todd from Onchain API. This tutorial is going to be showing you how to use MetaMask Smart Wallet Delegations with Onchain API. And specifically, we're going to show you how to store and automatically retrieve and execute delegations on behalf of your users in your TypeScript projects and products. So we're working in the Onchain API examples monorepo. Clone this repository. And if you cd into the TypeScript/delegations folder, this is where we're going to be doing the tutorial. First thing you want to do is copy the example env into an env file. And if we take a look at that env file, we need some credentials from Onchain API. So coming back to the Onchain API website, log in or create a free account, and click on the API Keys tab. Create a new API key if you haven't already, and give it a name, and then grab that key in secret. Place those here in your env file. The business ID is at the top right-hand corner of the Onchain API portal. Copy that and place it right there. And then lastly, you need a private key. So any private key will do. It does not need funds because we're going to be relaying transactions on behalf of this virtual user. And the last thing we want to set up in Onchain API, if we come to the Wallets tab, we want to create an Optimism wallet because this tutorial is going to run on the Optimism network. So create a new wallet, select Optimism, give it a name and a description, and provision that. So this is going to serve as our delegation relayer account. And be sure to put a little bit of Optimism ETH in it. You don't need very much, like $1 worth will do. That'll do dozens, if not hundreds of transactions. But be sure you have a little bit of funds in there to pay for the gas relaying. At that point, we're basically set up. We could run this, but let's walk through the script so you can understand what it's doing. So starting at the top, here's where we import our environment variables. There is some constants here that you don't need to mess with, but to explain to you what they do, the stateless delegator, this is the contract address of the MetaMask Smart Wallet implementation. It's actually the same on every network, so you don't need to change that. The other two things, this is the smart contract address for USDC on Optimism. We're going to be executing a function on the USD smart contract on behalf of this virtual user. And there is a Onchain API prompt ID. So this is used further down in the script to import all of the smart contract methods for USDC. If you want to change this, you can point this at a different smart contract. But if you do that, you'll want to change this one-shot prompt ID to the prompt ID of the smart contract. So if you come to Onchain API, click on the one-shot prompts tab, find the contract you want to interact with, click it, and then grab that prompt ID right there from the URL. Moving on, here's where we initialize the Onchain API client, and then we check to make sure that you did provision that server wallet for relaying, and if not, it stops here. The rest of the script is broken down into two components. There's a server-side component, which mimics the actions that have to happen in your web application, and then there's a server-side section. This is what would happen in your business logic on your backend. So walking through the client-side functions first, we take that private key and we create an account. So this kind of mimics creating an embedded account. So there's a client-side EOA that we have control over. And the first thing we do is we prepare an EIP 7702 authorization. So this is what is needed to upgrade the EOA to a MetaMask smart wallet. Now I want to emphasize browser extensions do not let you sign authorizations through like a JSON RPC method. So this has to be an embedded account. You can't do this with a browser extension. I just want to clear up that confusion in case anybody has it. Generate that key in the browser context. So we prepare that authorization and we're using that stateless delegator address, and we're doing this as a sponsored upgrade. So the executor is undefined. That just means that this isn't a self-sponsored upgrade. The next thing, we use the MetaMask delegation toolkit. There's a function to MetaMask smart account. Really all this does is give us a different object view of that VM client. It doesn't submit any transactions to the blockchain, but it tells us, pretend this VM client is a stateless 7702 style smart wallet. So then once we have that, we create the delegation. Again, this is from the MetaMask delegation toolkit, and it takes a scope. So this scope says what a third party is allowed to do on behalf of the user when they're not online. So in this case, we're saying the target is that USDC smart contract, and it can the only function that can be called is the approve function. So you could have multiple smart contract targets and multiple function selectors if you wanted to allow the third party to make other calls on the user's behalf. I'm keeping this one simple. There's also caveats that you can add in conjunction with the scope to further limit the delegation scope. Now, importantly, this delegation can only be redeemed by the to address, and we're setting the to address to be that one-shot API server wallet address. So if some other party got a hold of this delegation, they couldn't redeem this delegation unless they have access to that server wallet. So restricting that to of the delegation is important. Next, we sign the delegation with the smart wallet object. We sign it, which really under the hood is just a sign typed data. We get that signature and we pop it into the signed delegation object, and then we're done. Client side, that's all that happens. Client side is signing that authorization and signing a appropriately constructed delegation. Next, we come to the server side. Here's where one-shot API becomes super helpful. The first is that the delegation from the user can be stored in your one-shot API account so that it can be retrieved and used on demand. So this is a really important and really useful feature of one-shot API. You use the create delegation SDK function call, and we store that signed delegation linked to the target server wallet, and we index it based on the contract addresses that are in that delegation. So the USDC contract address, that makes it faster for one-shot API to look it up when I try to execute a function for the user. This next piece, you probably wouldn't need this in your backend logic, but it's here to keep the tutorial more automatic. We run assure on that smart contract address that we're executing. This just imports all of the functions available on that smart contract address into our one-shot API account so that we can call them. So then there's all the methods available on that smart contract. We find the approve function in that array, and then we're going to get that approve method ID. So showing you in one-shot API, I could come to the one-shot prompts, find a smart contract, import all those methods, and then they're available for me under my smart contract. So like if I clicked on USDC Sepolia and click the approve method for that smart contract, there's that contract method ID. That's really all I need. So you could take that ID, pre-import it, and then embed that as an environment variable in your product or project. And then here is where the interesting stuff happens. One-shot API can execute transactions as delegator. So what this means is take that contract method ID. Here's the input parameters, spender and value. I'm just putting here the spender is going to be the relayer address. It could be any address, whatever makes sense for your application, and then a value. And here's where we pass the authorization list. So I can execute as delegator and at the same time upgrade that wallet in one transaction. If I leave this part out, it's just a regular 1559 transaction. If I include this, one-shot API automatically turns this into a type 4 transaction. And importantly, MetaMask delegations are deeply integrated into one-shot API, so this handles automatically running transactions through the Singleton delegation manager. You don't have to figure out how to package all that up. One-shot API takes care of all that complexity for you automatically. And then this here, the memo field, this is just a helpful feature of one-shot API. You can actually leave messages attached to your transactions so that as your product runs and you're doing things for users, you can actually search that transaction history to look up what happened in a specific event or see if a particular transaction was run for a user. That memo field is super useful. But that's the run through of the script. creating that embedded wallet, signing the delegation and authorization, and then executing it and upgrading it in one single transaction. So let's run it. We'll do npm install first to install our dependencies. There's only two in this example, really, the MetaMask delegation toolkit and the one-shot API TypeScript client. And next we do npm run build to compile the project. And then lastly, we can run it. npm run start. And it prints some things to the screen just to show you what these objects look like. So this is kind of what the authorization looks like with the signature. And here's what a delegation looks like. This is what the components of a MetaMask delegation object look like, just for educational purposes. And then lastly down here, this is your one-shot transaction ID. So this ran successfully. If we come back to one-shot API and go to the transaction history tab, there's our memo. And this is the transaction that executed. If we click on the hash, we can see that this is actually a really cheap transaction to run. So this cost a fraction of a penny to generate a smart account and run a function for a user all in one step. So this is incredibly cheap onboarding. We're talking about almost the same amount of cost for reading and writing to Firebase. And then if we inspect this further, if we go to the authorizations, there's our authorization that we ran. So this upgraded the EOA to a MetaMask smart wallet. And then lastly, the logs. Here's our approval, because we ran an approval on USDC for the user. And this is the redeem delegation event. So this was actually emitted by the delegation manager. And One-Shot API packages up the function call, locates an appropriate delegation, and then puts all of this into a properly structured transaction and submits it for you. So that makes building products and projects that use delegations super simple and super cheap to build. And that concludes the tutorial. If you have any questions on this or want any pointers on how to build delegation-oriented on-chain products, hit us up in Telegram and watch out for other tutorials coming soon.